Illustrative Math, Geometry, Unit 1, Lesson 11 is called Defining Reflections. So our goals today are, I understand that the term reflection, both written and spoken, requires specifying a line of reflection. I can determine whether a figure is a reflection of another, and I can draw reflections of figures. All right, which one doesn't belong? All right, pause the video and come up with your best answer. If you really want to overachieve, try to come up with an answer for all of them, because each one of them could be correct depending on your explanation. All right, so figure 1. If you selected figure 1, a good reason would be the segment crossing line L is not perpendicular to line L. So AB here is the only one that's not perpendicular, so there's no right angle there. If you chose figure 2, a good reason would be the distances on either side of line L are not equal, or you could say it's the only one with no congruency marks, obviously because it's not congruent. But you can see here, this is 4, and this is 6. If you chose figure 3, this is the only one with the prime notation, so C and C prime. So that leads us to believe that C is the pre-image and C is the image with that prime notation. And then if you chose figure 4, the total length of the segment crossing line L is not 10 units. Okay, so AB is 10. AB is 10, 5 plus 5. C, segment C, C prime is 10 as well, but this one's 14. Okay, bunch of different reasons there. This one, just another review here too. This is still a bisector. It's just not a perpendicular bisector. This is perpendicular here on figure 2, not a bisector. 3 is a perpendicular bisector. So line L is a perpendicular bisector of segment C, C prime. Over here, line L is a perpendicular bisector of segment AB. It's perpendicular and it cuts the segment into 2 equal halves. All right, a little bit of definitions here. A reflection is defined using a line. It takes a point to another point that is the same distance from the given line, is on the other side of the given line, and so the segment from the original point to the image is perpendicular to the given line of reflection here. So if I look here, figure A prime is the image of A under the reflection across line M. So very important to understand 2 things happening here. One is it's perpendicular when you reflect it, and 2, it's equidistant. So this distance right here is equal to that distance as marked with the congruency marks right there, okay? So perpendicular and equidistant, okay? Make sure you understand that. All right. So this is one of those info gap things here. So they give you the problem. We need to like figure out what questions or what info we would need to answer this question. They don't give us both of those at the same time. So this problem card says triangle GEN has been reflected so that its vertices of its image are labeled points. So I'm going to go ahead and draw that triangle here. Triangle G, where's E at? E, N. So there's my triangle. So what would you ask? I would probably need to know what is the line of reflection, or do I, well, they're asking me what the image is. So this is the pre-image. So the image, so which, do they give me any points that are the images? Do they give me the line of reflection? Those type of questions would be good ones. So they do give us some images. So the image of A is L. So image of A is L. So the image of A is L. So they're not on the point. Think of this as A prime and this A. So basically, if I did a perpendicular bisector somewhere here of this segment here, that would be my line of reflection. The image of n is u. So the image of n is u. So here, think of this as n prime right here. So my line of reflection is somewhere over here. And the image of r is r. So here's the thing, r, oh, and it says the image of g is g. So this is g, this is g prime, this is r prime. So these two are the keys because they tell us that since the image is on the line of, is the same point, that means it's on the line of reflection. So I'll make my line of reflection red because r, red starts with r, and so does reflection. So that way you don't forget which is which. So here is my line of reflection. So you can see here for A and A prime or L, you can kind of see here, right there. And if I connected these ones, these would be a little bit easier to see because you can tell here, this segment here, it's perpendicular. You can kind of tell, we don't know for sure, but you can kind of tell it's perpendicular. You can kind of tell that these are congruent. If I put a point here, if I call this M, do I have an M on here? I don't. So AM would be congruent to ML. Okay, I'll get rid of the A prime. Same thing with the N and the U. I get rid of the N prime here, but same idea here. Okay, this would be perpendicular, and if I called this, I don't know, X, I don't think I have an X on here. UX is congruent to, I'll use two marks here. UX is congruent to XN, and they're perpendicular. UN is perpendicular to RG. Okay, so there you go. All right, let's try another one. Several points have been reflected across a line that goes through two of the labeled points. Precisely describe the reflection. So we would need to know either an image and a pre-image of a couple points, or we would need to know the line of reflection, or we need to know if any points and their image stay the same. All right, if I have points that stay the same as their image, then we know they're on the line of reflection. So let's take a look and see what the data is. The image of A is G. So I'm gonna do a line here. So A goes to G. Okay, so if I did a perpendicular bisector of this segment, I could get my line of reflection. So let's say I didn't have any other info here. Let's say that the rest of this, see, that was all I had. If I wanted to, I could do perpendicular bisector here. If I open this up, get this, and then move that over here, and get those intersection points. And basically, you could connect those intersection points. And the problem is, it's hard to tell. I can't tell if it's E or D. It looks like it's DN, but again, not very accurate here. Could be slightly off. These points are so close together. But I'll get rid of this here. All right, so let's get some more info. Image of D is D. Okay, cool. So this means that D is on the line of reflection. The image of I is V. So the image of I is V. The image of J is T. The image of L is Q. And the image of N is N. So N is, so I guess I was right when I did my picture. It looks like DN is my line of reflection here. So again, this is congruent to that, and perpendicular. Perpendicular, bisect. Perpendicular, bisect. They're congruent here. Perpendicular, bisect. So those are congruent. Okay? So there we go. So precisely describe the reflection. So I would say, I guess I need to do that here. Reflect points A, D, I, J, L, and N across line ND. Okay, you need a line of reflection. Did I ever answer that question? I don't think I answered that question on this last one. I just found the line of reflection. Whoops. So I guess I need to do that. So U, the image of N is U. The image of E is J. So let's see, G, E, N. So N. So E would go down to J. So I guess I didn't answer this question. Whoops. It's going to be G, E, N. G stays here. E will go to J. And N will go to U. So my new triangle is E, J, U. I'm sorry. That's not right. It's G, J, U. Sorry. G stays the same. E goes to J and to U. So I don't know why I did that. There it is. That looks better. That looks like a reflection here. So let me get rid of this here. You can see it a little bit better. So I'll write that down here. It's GJU. All right. So a couple other things. Kieran started reflecting triangle CDE across line M. So far, he knows that the image of D is D prime, the image of E is E prime. Annotate the diagram to show how he reflected D. So basically, D to D prime goes right there. And we know that this is perpendicular. We know that these segments are congruent. Use 3-edge and compass moves to determine the location of C prime. So I need to basically create a perpendicular line here that goes through C, perpendicular to M through C. So let's do it. So I'm going to open it up. Oh, that's not big enough. I'm going to make it bigger. Okay, once I find those points, then I put right at that little intersection point, same length right there, and then here. Again, same length right there. Let me move that so it's a little bit more accurate. right there, and then I make my perpendicular through C. See how it's perpendicular to M. And then I need to measure this distance from C to here to that intersection point, and then I need to mark that right there, which as long as, I guess it would be the same as this point right there. So I guess I didn't need to do that last step, but right here is going to be my C prime. Okay, so if I connect these, check that out. Does it look like a reflection across line M? Looks pretty good. Lightly shade the triangle. Okay. Write a set of instructions for how to reflect any point P across the given line L. Construct a line that's perpendicular to line L that passes through point P. Label this line as line P. Mark the intersection of line L and line P as point M. Construct a circle centered at M with radius MP. Mark the point that intersects the line P. So kind of what I did there at the end, but I guess I didn't really need to do that. As long as it's centered from here to here, I guess I don't really need to do the step 2. As long as this construction is perfectly centered around there. All right. Elena found C prime incorrectly. Elena is convinced that triangle C prime, D prime, E prime looks fine. Explain to Elena why C prime is not a reflection of point C across line M. So I'm going to just kind of connect these. And you can kind of clearly see here it's not equidistant. If I check it here with my compass, I mean, that's just one way to check. Move it over here. So we can see that they're not equidistant. This one's too big over here, this side. So I would say something along the lines of, distance from C prime to line M is not equal to the distance from C to line M. Okay. All right. So just a quick review here. A reflection is a rigid transformation, which means it preserves distance and size, that takes a point to another point that is the same distance from the given line, is on the other side of the given line, and so the segment from the original point to the image is perpendicular to the given line. Okay, so reflect with this picture here, I used some highlighter here, reflect A across line M. Okay, and there it is. Okay, you need an object to reflect, and you need to reflect across a line. Okay, so just another thing here, A prime is the image, and A is the, I call it the pre-image. You might just see it called the original. But there you go. All right, equidistant and perpendicular. All right, Lynn tried to reflect triangle ABC across line T. She knows something went wrong because the image isn't congruent to the original figure. Okay, you can definitely see that this is bigger. You could trace ABC and kind of see if it fits on top of it. What is one idea Lynn probably understands about reflections? What's one idea that Lynn doesn't understand about reflections? Reflect it correctly. Okay, so let's see here. If I connect here to there, I would say she does not understand that you need to be perpendicular, because this doesn't look perpendicular. Okay, so I would put here one thing that she doesn't understand. I'm going to start with two because I just saw it first. She doesn't understand that the image must, how about the segment connecting the image and pre-image must be perpendicular to the line of reflection. Okay. What does she understand? I would say she understands that the image goes on the other side of the line of reflection. She definitely got that right. So to do it correctly, I have to use my compass and construct three perpendicular lines here. I'll tell you what I'm going to do just for the sake of time. I'm going to make a perpendicular line. And again, I would not recommend doing it this way, but I'm going to just measure an angle with a compass. So I'm going to line this thing up right there. And then make sure that I'm at 90, which looks good. So this will be parallel. If I move it, I'll just clone three of them. So there's that line through B. There's that line through A. And then let's do one more. I need one through C. There's my line through C. And then I'll tell you what I'll do. I'll just use like my compass to measure the distance here. Okay. Just to speed things up a little bit. Swing that over here. This will give me my A prime right there. Right there, that'll give me my C prime. And this will give me my B prime. So I'll just mark those points here. So that's my A prime. This was my C prime. And on that line was my B prime. Okay, so there's my triangle. All right, a little off there on my sketching of it, but there you go. So, all right, well, that's it for this lesson. Hope you enjoyed it, and we'll see you next time.